Hi, welcome back. In this section, we're going to talk about where do I go from here? We're going to talk about security and quality engineering and how they fit into DevOps. Talk about the role that compliance plays in an organization that practices DevOps. We'll talk about sales, marketing, and beyond, parts of the organization that we traditionally haven't talked about in DevOps. And last, we'll talk about how to become a learning organization and get some resources that you can use to expand your DevOps knowledge even further. In this video, we're going to talk about security and quality engineering. In this video, we're going to take a look at, is DevOps more than just dev and ops? We're going to talk about the role that quality engineering and security can play in the development of our software, and then we're going to look at some examples of what they can do. W. Edwards Deming. We named a chatbot after him. The chatbot wasn't really so focused on quality, but W. Edwards Deming was. He was famous for bringing quality as a mindset to Toyota manufacturing. And he had a quote that we really like. Cease dependence on inspection to achieve quality. Eliminate the need for inspection on a mass basis by building quality into the product in the first place. What Edwards Deming was saying is that we can't inspect quality in afterwards. We need to make that a part of the way that we develop our software. We talked about in the second way how we feed back things about the way that our software runs into development. This is an opportunity to feed quality back into the way that we develop our software. We want to deliver a quality product to our customer. We can't be like the old days where they'd say, we develop our software and it's ops problem now. In the same way, we can't say, well, we developed our software, it's quality engineering's problem now, and they're supposed to make a quality product out of what we delivered to them. That can't happen. You can't put that in at the end. We need to have quality engineering involved from the very beginning. They can do things like design reviews. When we're designing the software, when we're designing the system, how do we handle failures? What inputs are we supposed to expect? What inputs would break things? How are we going to test those kinds of things? If the user does this or the user does that, how do we expect the software to respond? We need to incorporate quality in from the very beginning in the design of what we're actually going to build. And then we're going to put that quality engineering mindset into our continuous delivery pipeline. The quality engineers are the experts in testing. When we're doing continuous delivery or continuous deployment, we're just maximizing the automation of our testing as much as possible, and the quality engineers are experts in that. Does that mean they can't do exploratory testing as well? No, but we want to have them involved as early as possible, and the beginning of our continuous delivery pipeline is about as early as we can get, except for maybe the design review. So we want the quality engineering teams to be involved in helping us to build the CD pipeline. They're the experts on how to maximize the return that we're going to get out of the investment that we make into continuous delivery. They can also help with things like test design. How do people write their tests? When people write their tests, we want to make sure that we're testing the right things. The quality engineering teams can help us with design. They can give advice. They can be real partners in software development. If I have operations people who are trying to write unit tests or integrations tests, or if I have developers who are trying to write unit tests or integrations tests, and they're not sure about what the right way to test something is, there are experts who know how to do that. So get quality engineering involved early in the process. And the last thing that they can be involved in, among other things, is destructive testing. So places I've worked, we did destructive testing with quality engineering before any service went live. And they had a checklist. And the checklist would say things like, this is what it looks like when it's operating normally. This is the failure that we're going to induce. This is the expected behavior for that failure. And this is the observed behavior for the failure. Nothing goes to production without destructive testing. We know it's ready because we tried breaking it first, and if it responds correctly, then that's great, and if it doesn't, then we go back and we try to fix it so that all of our failures are expected failures, at least for the things that we thought about. We don't want to find out that some piece of software is broken or it's misbehaving once it's in production. We already know it's way cheaper to find things during development and as early in development as possible. And destructive testing is also an opportunity to get operations involved, so they know what the remediation steps are if there's things that need to be fixed by people in operations. They can practice things, they can see it, they can understand the documentation. So destructive testing can be an important part of having quality engineering involved in the process. But what about security? Well, Tahir El-Gamel, the father of SSL, said, "Security is just an aspect of quality. Just like quality engineering, we need security to be involved throughout the development. We don't have a quality piece of software if it's vulnerable to exploits, or it can crash based on user input, or it reveals passwords, or it leaks things from the database. That's not quality software. We don't want downtime for our customers. So security needs to be built into the product just like quality engineering builds things into the product, because security is just an aspect of quality." So again, security can be involved in design reviews. They can say, "We are not allowing any passwords in plain text to be on the disk. You can't pass passwords on the command line, because if you're on a Unix system and somebody does a PS, they could see your passwords." They can mandate, "This is how we're going to build our firewalls. This is where we're going to need strong authentication or strong authorization." All those things can be important parts of the design review. We want a high quality system that's resilient to attacks from the very beginning, which means we also can have security involved in the continuous delivery pipeline. Security should have a voice there. They should be running automated security tests, just like we talked about when we talked about continuous delivery, as part of the continuous delivery pipeline. One of the things they could run there are static analysis tools. They'll do an analysis of the code, and they'll find out whether or not that code is vulnerable to a well-defined set of tests. And this is important because you can actually feed back the results of that analysis to your developers and say, "This is a class of problem that we noticed that's in your code. Here's how you resolve that class of problem." And then all of the quality of the code that's going through this continuous delivery pipeline is going to be better, of higher quality, more secure, more resilient. Another part that security can be involved with is artifact integrity. Is the software that I'm testing the same software that's being deployed to production? We can do things like signing our artifacts. We can do checksums. We can do all kinds of things. If I have a Docker container, is it the Docker container that I use in dev and test the same Docker container that I use in production? This integrity of these artifacts is super important because we want to know that we have the quality software that we tested as the quality software that's running in production. We don't want some kind of, "Oh, well, we made a bunch of changes after it came out of development and we're going to do this different piece of software in production," because we don't know how that software is going to behave, and that's not necessarily quality software. So we had DevOps, and now we're going to have quality engineering involved, and we're going to have security involved. So does that mean that we need a new name? Are we going to have DevSecQualOps or something weird like that? No, we don't need anything like that. DevOps is DevOps. It's more than just development and operations. DevOps is an entire organization trying to deliver high-quality software to production. There are lots of opportunities for different parts of the organization to be involved. And we're going to talk about some of the other parts of the organization that can be involved in the next video when we discuss compliance. I'll see you there.